welcome back. And before we start talking more about redox reactions, building from what we have been doing previously, let me end the section about bonding by talking to you about how bonds are formed. One very crucial thing is that when bonds are formed, there are energy changes. That's one very important thing to understand. Let's go through it. When a bond is formed, energy is released. The released energy is called the bond energy. And if you are to break a bond that is formed, you would need energy to do that. And the amount of energy released when a bond is formed, which is the bond energy, equals to the amount of energy required to break that bond. So when you break bonds, you need energy. And when new bonds are formed, energy is released. Okay. Now, down here I've got a set of bonds that tells you the amount of energy released when such bonds are formed. But this is for you to go and look at, study, and check how it works. All right. Now let's go straight to redox reactions. Let's start talking about what we call a galvanic cell. What is a galvanic cell? In a galvanic cell, we do have energy changes, and it's important for you to understand this and note. In a galvanic cell, the energy conversion that happens there is that chemical energy is converted to electrical energy. Okay? So we've got chemical energy that is turned into electrical energy, so we can use that electrical energy for our daily use if we want to. Okay? This galvanic cell is made up of electrolytes. What are electrolytes? Solutions that conduct electricity, or solutions made up of ions, with ions that are free to move. Okay, again in a galvanic cell we will also find electrodes. We have an electrode that we will call the cathode, and the electrode called the cathode is that electrode where reduction occurs. Remember, reduction, gaining of electrons. And we would also have the anode. What's the anode? The anode is that electrode where oxidation occurs, right? And another part of a galvanic cell that is so important is something called the salt bridge. This salt bridge is made up of a saturated solution. Saturated meaning that you have dissolved enough solute there, you can't dissolve anything more in it. Okay, so that's what makes up the salt bridge. What does the salt bridge do? It completes the circuit, so it acts like a switch. And lastly, the salt bridge maintains electrical neutrality between the two electrolytes in your galvanic cell. Now let's have a look at how does this galvanic cell look like. Here it's an example. This is a zinc copper galvanic cell. All right. Here is the salt bridge we were talking about, made of a saturated solution. It maintains electrical neutrality between the two solutions, between the two electrolytes. This is an electrolyte of copper sulfate, and this is an electrolyte of zinc sulfate. Okay? Now here we've got an electrode of zinc. This electrode of zinc, here we're going to have oxidation happening. Okay? So zinc is going to lose electrons, and because oxidation will be happening here, this will be called the anode. Okay? How is that oxidation happening? The zinc atoms are losing electrons to give us the zinc ions plus 2 electrons, like that. Okay? Now, on the other side, we have got the copper electrode. This copper electrode is the cathode. Okay? Cathode, because it is attracting the positive ions there. But what we know, how do we define a cathode? A cathode, because here, this is where reduction takes place. A cathode is where reduction occurs. All right? Now, how does that reduction occur? We know that inside the solution we have got the copper 2+ ions. Those copper 2+ ions receives electrons to become copper solid. So that copper solid will be forming around this electrode here. Okay? On the other side, zinc is losing electrons, and zinc 2+ ions are getting into solution as atoms of zinc lose electrons. What do you think will be happening here with zinc? The zinc plate or the electrode will be eroded. It will be becoming smaller and smaller as time goes on. So it will lose mass. So there will be loss of mass there. This side, on the other hand, we see copper being formed on the side of this electrode here. What do we expect to see happening around the mass of the copper electrode? We see that there is gaining of mass. Okay? So there shall be gaining of mass there. Right. So that is what is happening there. Now remember here, the copper ion 2+ is blue in color, hence the blue color that you're seeing there. Now, as more and more of the copper ions are taken out of solution to be copper solid, copper is brown in color, brownish. Okay, so that will mean that this blue color would actually fade. Okay, it will fade. Blue color will fade away. Right. See you in the next section.